So the purpose of this video is to go through some past paper questions and some questions that are in your notes regarding the test for ions and the test for gases. So make sure that you've watched video 1 or you've read the notes and learnt the notes on test for gases, test for ions. If you haven't done that, this video is probably a bit pointless, to be honest with you. So having looked at the previous video or learnt the topic, okay, let's go through the questions that follow and see how we get on with these. So I'll kind of talk you through them. I think it's probably a good idea that if you have learnt the stuff, that you pause the video, look at the questions yourself, and I will go through the questions then whenever you hit play again. So we've got compound S, which is a white ionic solid. So the first thing that you guys should be taking from that is that it probably contains aluminium ions, zinc ions, magnesium ions. Really any group 1 or group 2 compound could be in there, plus the aluminium, and the other one is an ammonium ion. So that it doesn't narrow it down massively, but at least it gives us a bit of a start. We've got a white precipitate with barium chloride. So as soon as you see white precipitate with barium chloride, that white precipitate is barium sulfate, telling us that there was sulfate ions in whatever this white ionic solid was. And whenever we had excess sodium hydroxide was added to the solution, another white precipitate was observed. So we have excess sodium hydroxide, we've got a white precipitate. The only ion that gives us a white precipitate with excess sodium hydroxide is, of course, the magnesium ion, the zinc ion and the aluminium ion. Both we dissolve in excess sodium hydroxide, so we could rule those out. So therefore, our compound, very simply, is magnesium sulfate. The second one, where I talked about a commercial moss killer, and it was made up in a solution with some sodium hydroxide, so we must be testing for a metal ion. And we got a green gelatinous. Gelatinous means jelly-like precipitate. That's the first question, by the way. So that's sort of, if we go back to, even if I go back to here, you'll see here, that's sort of jelly-like precipitate, so not a heavy, dense. These are all gelatinous precipitates that I'm circling here now. So gelatinous simply means jelly-like. Right, so we had to write an ionic equation for the formation of the precipitate. Right, so if it's green, that tells me there must be iron 2 in here. The ionic equation is you have iron 2 plus, we have to cancel out the plus charges with hydroxides. Each hydroxide is -1, so I need 2 of those. And then my formula of my iron 2 hydroxide is as so. What cation must be present? Well, it has to be, if it's a green gelatinous precipitate, iron 2. The moss killer was thought to be iron 2 chloride. What reagents would the chemist use to identify the negative ion present? Well, for iron 2 chloride, you would first of all dissolve it in dilute nitric acid, and the second thing then that you would do is you would add silver nitrate solution. Make sure you say solution, and if it was indeed a chloride ion, you would at that point get a white precipitate, silver chloride. Next question. So we'll go through a lot of text here. Let's go through it and find out the key points. So chemists tested a solid ionic compound, so we know it's ionic. Okay. They dissolved it in nitric acid, and as they did that, they saw some fizzing. Right, that's going to be important. So when you put something into acid and it fizzes, that's your positive test for carbonate ions. The resulting solution was used in the flame test. We got a brick red colour. Brick red tells me that I have calcium ions in there. The solution then was split into 2 separate test tubes. One test tube with silver nitrate added. You got a cream precipitate. That tells me I've also got some bromide ions in here. Okay. And the other test tube had some ammonia solution added until it was in excess. And we got a blue precipitate which dissolved to a blue solution. Well, that is without a doubt copper 2 plus ions. Identify 2 possible salts. Well, I could have copper bromide, I could have copper carbonate, I could have calcium bromide, or I could have calcium carbonate. So any of those 2 would be fine. Okay, so as I said, copper bromide, copper carbonate, calcium bromide, or calcium carbonate, any of them. The blue precipitate that was formed was the copper 2 ions with the hydroxide. And same thing again, we need the right number of hydroxide ions to cancel out the charge on the metal ion. The metal ion is 2 plus, so my precipitate is that. The answer is that. I don't have to write the whole equation. Right, next one, let's go through this. With a student was doing some chemical tests and some mouthwash, and they added a few drops of aqueous ammoniate, and then they added excess ammonia, and they got a white precipitate. So with excess ammonia, the only ion that you know that gives you, there's two ions you know that give you white precipitate, So at this point, we're thinking there's aluminium ions in there, and there are magnesium ions in there. The student then added some dilute nitric acid followed by silver nitrate, got a yellow precipitate. That should tell you that you have iodide ions in there. And the student concluded that the substance was magnesium iodide. Do you think it was a valid conclusion? Well, no, it's not a valid conclusion, because he should have tested further with sodium hydroxide to check whether it was aluminium or magnesium. So it's not quite valid, no. What other reagents should they have used? Well, they should have used sodium hydroxide. That would have allowed them to differentiate between the aluminium and the magnesium, because the aluminium will dissolve in excess sodium hydroxide, the magnesium will not. Give the possible precipitate of the the possible formula of the white precipitate. Well, the white precipitate could either be that, or it could be that. Either of those answers would be fine. Two students were unsure if iron tablets contain iron 2 or iron 3. How would you confirm? Well, very simply, you would add dilute sodium hydroxide solution, yeah. And if you get a green, I'll just write gel for gelatinous precipitate, that tells you that it's iron 2. If you get a sort of a brown or orange brown, still gelatinous precipitate, well, that tells you that it is iron 3. Simple as that. Okay, next one, the student has 3 white solids. So when they're white, we're thinking magnesium, aluminium, zinc, ammonium, any group 1, group 2. So again, it doesn't help us loads, but it gives us a bit of info. Rules out coloured ones like iron, 2, 3, copper. Okay, and they all have the same anion, but different cations. So that's important, bear that in mind as we go through the question. The students need to identify the cations using dilute sodium hydroxide. Okay, what's the first thing the student would do with the 3 solids? Well, the first thing you have to do with them is dissolve them in, and this is important, deionize. I just write di, water. Must say deionize water. If you don't, you will not get the marks. The student used dilute sodium hydroxide to test the 3 solutions. Okay, in solutions A, B, and C, a white precipitate forms, which redissolve in excess sodium hydroxide. Okay, in solution B, the white precipitate remains at excess sodium hydroxide. Okay, I think that's meant to be not, the B is not meant to be there, sorry. So let's do that again. In solutions A and C, the white precipitate forms, which redissolves in excess sodium hydroxide. So that tells me that that is aluminium, or it is zinc 2 plus ions. And in B, the precipitate would remain, so that is magnesium 2 plus ions in there. An ionic equation for the hydroxide ions reacting in B. Well, B is with magnesium ions, so we have magnesium, which is 2 plus. We need hydroxide ions, so we need enough of them to cancel out the 2 plus charge. So there we go, that's our precipitate, and that's our ionic equation. What would the student now do to identify the cation in A? Okay, so we said A was with dilute sodium hydroxide, aluminium or zinc. The student would then have to take fresh solutions of A and dissolve them up in deionized water again. And they would then have to add dilute and excess ammonia. Okay, and if it was aluminium, the precipitate will remain in the excess ammonia, and if it is zinc 2 plus ions, the precipitate will dissolve to a colourless solution in the excess ammonia. So you can use the excess ammonia to differentiate between what we weren't sure of here, the aluminium, or was it zinc. What does gelatinous mean? Well, we've already had that. Okay, student tested for the anion using dilute nitric acid followed by silver nitrate. They observed some fizzing initially, right? So that straight off tells us we've got some carbonate ions in there and then a colourless solution on the addition of silver nitrate. If there's a colourless solution on the addition of silver nitrate, that means that there is no chloride, bromide or iodide. There's no halide ion present. So the identity of the anion is therefore the carbonate. Write an ionic equation for the reaction caused by fizzing. So the fizzing is caused by the carbonate ion reacting with the hydrogen ion, the acid from the dilute nitric acid, and that will give you water, and you will get carbon dioxide. What additional tests could it carry out to confirm the anion present? Well, you would, at that point, simply check that the gas was definitely carbon dioxide, and you would put that through lime water, and the lime water will turn cloudy or milky. So that will definitely tell you that your original ion back here had to have been a carbonate. Give the formula of 3 anions which have been proven not to be present in A, B or C. Well, not to be present is the 3 that I spoke about up here. So that's your 3 halides, chloride, bromide and iodide, because you didn't get a precipitate with silver nitrate. Next, we're going another white solid. We've spoke about what white solid means already several times. It contains a mixture of 2 different metal salts. They have a common cation, okay, and we're tested to identify these compounds. Right, let's have a look. So we did a flame test first, and we got a crimson flame, okay, so crimson flame. That's telling me I have a lithium ion in there. The chemist then made a solution of the solid, added a few drops of barium nitrate solution, so we're adding barium ions is the important part of that. We got a white solid. Barium ions with white solid are producing white solids with colourless solutions. Tell me I have sulfate ions in there. We took a fresh sample and we added dilute nitric acid followed by silver nitrate. We got a cream precipitate. That tells me I have bromide ions in there. Give the possible formula of all the ions present. So all the ions present are lithium plus, sulfate 2 minus, and bromide -1. So remember, put the charges on the ions, and it does say the formula, it doesn't say the name, so you can't write the names. Okay? Right, let's have a look at some past paper questions then. So some analytical tests were carried out to identify ions present in several compounds. Write the formula of the anion and the cation based on the results below. So we have a white precipitate when we added some barium chloride. Again, that's kind of like the last one. That's a sulfate ion. Okay, so we have to write the formula of the anion or cation present. Well, we can only tell the cation or the anion there, sorry, that's a sulfate. A white precipitate was reduced when we added some sodium hydroxide to a salt, and the white precipitate remains in excess sodium hydroxide. Well, the only one that remains in excess sodium hydroxide must be magnesium ions. We added dilute nitric acid to a salt, and a gas was produced. As soon as a gas is produced with an acid, you guys hopefully now recognise that that is indeed a carbonate. It turned lime water milky, so it's definitely going to be a carbonate ion. A flame test was carried out. We got a crimson flame, same as we had in the last slide, I think, lithium +1 ion. Okay, identify the cation present here. The cation flame test, potassium ion. I think it's the first time it's popped up. The anion present, we added silver nitrate. We got a yellow precipitate. Iodide ions. Formula is K is +1, iodine is -1, potassium iodide. Some analytical tests. I think we just had that one. Right, let's have a look. This time we've got a table to fill in, but we've got to put in our observations based on what they have. So we have sodium ions and we have a flame test. So the sodium ions are yellow. You can write orange or yellow, either or is fine. Okay, don't write both. You're not allowed to do that, believe it or not. Okay, we've got zinc ions here, and we're adding with a little bit of sodium hydroxide and then excess sodium hydroxide. Zinc ions will, in both instances here, you'll get first of all, a white PPT to begin with, and that white PPT will dissolve, and it will produce a colourless solution when it does dissolve. Barium chloride, we had sulfate ions here. Well, barium chloride, you should know by now, with sulfate ions, white precipitate. Silver nitrate chloride ions, well, it's exactly the same as 3. a white precipitate. Ionic equation for what's happening in 4. The silver ions, which are +1, are reacting with the chloride ions, okay, with aqueous chloride ions, and silver chloride is produced. That's a solid. That's our precipitate. Write the formula of the 2 different compounds which could be present in Z. Well, Z, we've said, has got sodium ions in it, and we've also said it has, or we've been told, sorry, it's got chloride ions. Okay, and it's also got zinc ions. We have to write the formula, remember, and sulfate ions. Okay, you could also, if you wanted, have zinc sulfate. Okay, and you could, sorry, sodium sulfate and zinc chloride. Any of those 2 would be fine. Right, drugs contain metal compounds may be used to treat different medical conditions. An excess of hydrochloric acid in the stomach can cause indigestion, and acid tablets containing calcium carbonate can be broken down to relieve the symptoms. State the observations made when an antacid tablet containing calcium carbonate is dropped in a beaker of dilute acid. Well, this is kind of acid plus carbonate. So first thing that will happen is we will get fizzing. Okay. Second thing that will happen is that the tablet will eventually disappear, and the final thing is it's a calcium salt that's produced. That's a group 2 salt, so we will get at the end of it all a colourless solution. Okay, a balanced equation for calcium carbonate plus, oh sorry, it's not that, plus hydrochloric acid. Metal plus carbonate gives me salt, which is calcium chloride now, plus water plus carbon dioxide. Formula of aluminium oxide is that. Colour of aluminium oxide, remember that aluminium oxide is a white, well, just white, that's the colour. It's a white solid. I don't need to write solid, it doesn't ask me for that. Flame colour here, these are all getting very samey now. Yellow or orange, fine. Calcium, remember it's a 2+ ion, make sure you get your charges right. Barium isn't actually on the GCSE spec anymore, but it's kind of a nice apple greeny colour. Okay, people who suffer from anemia very often prescribe iron supplements in the form of iron 2 sulfate. Describe in detail how solid iron 2, so it tells you it's a solid, that's going to be important. It can be tested to confirm it contains iron 2 ions and sulfate ions. You've got to do the chemical test for iron 2 and the expected result, a balanced ionic equation for that, a chemical test for sulfate ions, expected result, and ionic equation. So this can be read up very, very easily. So first thing we do is we remember we dissolve, okay, our tablet in, and remember, deionized water. Okay, we then take some of that, let's say 2 cubic centimeters, okay, and we add dilute sodium hydroxide slowly, and then we add it in excess, and you will get a green gelatinous precipitate. Okay. The equation for that is Fe2 plus 2OH minus goes to iron 2 hydroxide. That's all the marks for the first one done. The next thing to test for, we'll take again a fresh sample of 2 cubic centimeters of the solution from up above. Okay, we will add a few drops this time of barium chloride solution, aqueous, important you say that. From that you will get a white precipitate. Okay, the ionic equation for that is barium ions from the barium chloride, okay, plus the sulfate ion from the solution, both aqueous, form your white precipitate. Your white precipitate is a solid of barium sulfate. There you go, full marks. Describe the chemical test to positively identify the cation and the anion in magnesium iodide. Remember again, it's solid, so the first thing you would tell the examiner is that you will dissolve it in deionized water. Okay, the next thing you'll do is probably take roughly 2 cubic centimeters to that, and you will add dilute sodium hydroxide and the magnesium ions, the PPT, the white precipitate, I should say white actually. The white precipitate remains. Okay, I should also say that my sodium hydroxide here is in excess, so you get a white precipitate and the white precipitate remains. I don't need to do the ammonia reaction on that because aluminium and zinc both redissolve with excess sodium hydroxide, so I now know it's magnesium iodide. I take 2 cubic centimeters of it again, and I add a few drops this time of dilute nitric acid, HNO3, dilute nitric acid. Then I add a few drops again of dilute silver nitrate, and remember you've got to say that's a solution. Okay, and if there's iodide ions in there, I will get a yellow precipitate. And that's all the information you need to get full marks, guys. Describe how a flame test is carried out. Well, just make sure to learn it. You dip nichrome wire into concentrated hydrochloric acid and then into a hot blue flame until it burns clean. You then dip it back into the hydrochloric acid and then into your sample. You then dip it back into the edge of a clean blue Bunsen flame and you observe the colour. Okay. Right, use the information in the table, the questions to name the cation present in test 1. Test 1, we did a flame test on it. We got yellow. Well, that's sodium ions. Okay, sample 2, the sample was dissolved in DI water, sodium hydroxide was added. We got a white precipitate that redissolves in excess sodium hydroxide. Well, that could be aluminium ions or it could be zinc ions. We added then, dissolved some fresh stuff up again. We added barium chloride and we got a white precipitate. So that tells me that I have got sulfate ions. Okay. So those are the answers to all of the questions that we have on there. It says suggest the names of 2 compounds that may be present in the mixture. Okay. So you could have sodium sulfate, aluminium sulfate, or zinc sulfate. Any of those 3, in actual fact, would be fine. And an ionic equation for the formation of the precipitate in test 3, well, we've kind of had that several times by now, haven't we? So it's barium ions, which are aqueous, plus the sulfate ion, which is also aqueous, goes to barium sulfate, which is a solid, because that's your white precipitate. Okay, so I think this is the last question, guys. We've got X, Y, and Z. Based on the results, we've got to write the formula of the anion and the cation present in X, Y, and Z. Well, let's have a look. First of all, we have a green precipitate. Well, that's definitely telling me that I have got in X iron 2 plus ions. Okay, barium chloride, I have a white precipitate. That's telling me I've got sulfate ions. Okay, there's nothing happening, so I have no halide ions there. In Y, I have a yellow flame colour. That tells me I've got sodium ions. I have a yellow precipitate down here. I have iodide ions. I have a brown precipitate with here. That tells me I have iron 3 plus ions. And I have a cream precipitate here. That tells me I have bromide ions. Name the white precipitate formed by the barium chloride solution. Well, that is, and it tells me to name it, not write the formula. So I'm going to do exactly that. It is barium sulfate. There you go, guys. That's lots of questions done. If you can do those, you are going to have very few, if any, problems in the test for ions and gases questions. So good luck. All the best.